Hello, this is Dr. Bagli, your database instructor, and today we'll be listening to the recording on Chapter 4 of the ER book, the Basic Entity Relationship Diagram chapter of the ER book. By now I hope that you have read the material for the first read and covered the material that I have already presented, and the basic idea in the beginning material is I'm trying to present basically what a database is. So you should have gotten from there that a database is a collection of related material or a collection of related data. A database by definition is a collection of related data. In this chapter, we'll be talking about the basic ER diagram and just some of the very beginning concepts. Now, what I will be doing is, although I have a set of slides up on the screen, I'm not going to go slide by slide, but I'm going to focus you on the important things that will make the discussion easier, and it's really up to you to read all the slides and read the chapter and go over the material in detail. So let's just skip over and go to slide number 4. Rather, let's go to slide number 5, which talks about database definition. Okay, so an ER diagram. What is an ER diagram made of? An ER diagram is made of entities, relationships, and attributes, as you can see on slide 5 here. Well, why do we do ER diagrams? Why are we even talking about ER diagrams? Well, the basic idea is that we are trying to model and design a database. And as we try to model and design a database, usually pictorial representations are easier for people to understand, and an ER diagram is a visualization where we try to model a real-world database, and we model the database in terms of entities, relationships between the entities, and the entities are described by attributes. So basically, using an ER diagram, we are trying to model a database in the real world. So an ER diagram is a modeling scheme. It is a method of visualization to present the data visually so that it makes it easier to understand. And ER diagrams, as you will find as the semester progresses, ER diagrams really help in understanding a relational database, and if you do an ER diagram correctly, you will be able to correctly translate it into a relational database, and that is what we are hoping to do, and we will progressively do this as the semester progresses. So let's start off with a few definitions here. What is an entity? An entity is something about which we store data. So examples of entities. Well, a student would be an entity because I want to store information about a student. Well, what information do I want to store about the student, the entity student? Well, I want to store the student's name, the student's social security number or student number, the student's major, student's address, student's phone number. Every one of these qualities like name, major, address, etc., every one of those are called attributes. So basically an attribute defines or explains an entity. So all entities have attributes, more than one attribute. So an entity is something about which we store data. For example, we want to store data about a student entity, or we want to store data about a car entity, or we want to store data about a school entity. Say, for example, I want to store data about a car entity. I would store information like, for example, the name of the car, the color of the car, the make of the car, the model of the car, Every one of those pieces of information are what's called attributes. And car would be the entity. So now if I have a student entity and a car entity, I need to know what the relationship is between the two entities. So a relationship is an association between entities. So entities are generally nouns. Relationships are generally verbs or verb phrases. We try in the ER diagram, we actually are going to be using what's called a chain-like ER diagram, and I've mentioned that a couple slides down the road. We use a chain-like ER diagram mainly because the chain-like ER diagram is very descriptive. It names relationships, which makes mapping to the relational database easier. So we basically now have an idea of what an entity is, what a relationship is, and what an attribute is. So going to the next slide. Database modeling starts with the questions, what is to be stored? This question can be answered by anyone. So what is to be stored will determine what the database will be. Okay, so the first step in the ER design methodology is to select a primary entity, show its attributes, and draw an ER diagram of our primary entity. Okay, I have discussed the attributes, selecting attributes a little, but this slide talks about what type of information about our entity would we like to store, and that is what would be the attributes. So once you've selected an entity that you would like to store information about, what are the attributes that you would like to store information about? That's what would be the attributes. Now there are many different kinds of ER models. There's the chain-like model, there's the Oracle-Barker-like model, there's the Bettini model, and there's actually a whole bunch of other more models. But in this course, we will be focusing on the chain-like model, and you'll pretty much know the reasons why, because you'll pretty much see that what the chain-like model does is the chain-like model is very descriptive and really helps us translate into the relational database very well. So that's why we use the chain-like model. So in the chain-like model, we have some conventions. Okay, entities are shown in boxes, attributes are shown in ovals. Okay, looking at slide 10 now, we have an entity called employee, which has three attributes: name, department, and address. Notice that the entity is in a rectangle, the attributes are in ovals, and there's a line connecting an entity to an attribute. So that's how you know that that attribute belongs to that entity. Okay, now, there are many different kinds of attributes. There's what we call a simple or atomic attribute. There are composite attributes. There are multi-valued attributes. And there are derived attributes. And each of these attributes actually, once we translate them into a relational model, have a name and a description and a format, but we won't worry about that in the ER model. We'll just worry about the different kinds of attributes. Then there is also what's called a key. A key is an attribute that is considered a unique identifier for an entity, which means it will uniquely identify a particular entity. That's what a key is. So for example, in a student entity, a student number would be used to identify a particular student. So that would be the unique identifier, and that would be the key. Okay, I think we just screwed up on the slides, so I'm just going to try to go back on the slides here. Somehow I jumped the slides and went off to the last slide. And getting ourselves back, we should be back on slide 12. Okay, so what is an atomic attribute? An atomic attribute is an attribute that cannot be subdivided or broken up any further. For example, if we have something like an employee number or a student number, how would you break up a student number? You couldn't. So that would be an atomic attribute. Versus if we had an attribute like address, you can break up address into city, state, and zip. Or, city, state, and zip. Or street, city, state, and zip. So an address would not be considered an atomic attribute generally. Whether an attribute is atomic or not actually is a relative term, because, for example, an attribute like age in an employee database would generally be atomic. Or rather, let me give you a different example here. Age was not a very good example. Let's take the birth date example. In an employee database, the birth date example, the birth date attribute may be considered atomic because you would just store the birth date. You would not worry about breaking it down into day, month, and year. But if you were creating a database, say for example, premature babies, it may be important for you to store the day, the month, and the year separately in that database because it would be very important to know how many days that baby is old. So since I want to know the day attribute separately and maybe the month attribute separately, the birth date attribute in a database created for premature babies may be not atomic. But the birth date attribute in an employee database, where it doesn't matter whether the person is 56 years old or 36 years old, okay, we basically, maybe we just want a ballpark figure of how old the person is, so we don't really care of breaking down the attribute any further than just the birth date. Okay, so in that case, that would be considered an atomic attribute in that database. But basically, the definition of an atomic attribute is whether the attribute can be broken down any further. The next kind of attribute we have is a composite attribute. A composite attribute is an attribute that is made up of separate parts. For example, the address attribute could have city, street, city, and state, and maybe zip. And the street, city, state, and zip could be the composite parts of the address. Okay, again, this is a relative term. In a particular database, you may want to leave it as address. In another particular database where they are concerned about which city the person came from or which state the person came from, we may have to break it down into street, city, and state, and zip maybe. So, it's a relative term, but the definition of a composite attribute is an attribute that is made up of other attributes that it can be broken down into. Okay, so the next slide shows an ER diagram with composite attributes. So now we have the same ER diagram that we developed a few slides ago, and now the ER diagram has the composite attribute address, street, city, and state. And note how the composite attribute is shown. Okay, it comes off the address attribute. Okay, so we have the ovals linking into another oval address. So we have the oval street linking into the address oval, and that is a composite attribute. An address links into employee. So address is a composite attribute. Street, city, and state, however, are atomic parts of the composite attribute. The next one we have is the multi-valued attribute. A multi-valued attribute means, or rather, let me give you the definition of a single valued attribute. Say, for example, you have a student entity, and the student has a student number. The student is supposed to have only one student number, so that is a single valued attribute. Or the student has If you want to say the student can only have one major, then that would be a single valued attribute. Or if we have something like class, where where we put in whether the student is a freshman or a junior or a sophomore, the freshman or the sophomore or the junior, and the student can only be either a freshman or a sophomore or a junior or a senior. So that is a single valued attribute. A multi-valued attribute is an attribute where you can have more than one value for that same attribute. For example, if I want to list all the schools that the student went to previously, that could be multi-valued because the student may have gone to more than one school previously. So that would be a multi-valued attribute. How do we show multi-valued attributes? Well, if you look at slide 16, which is the next slide, you have the department. The department is shown in double ovals, and when we have two ovals on an attribute, it is a multi-valued attribute. So department is considered a multi-valued attribute of employee. So in this case, an employee can work in more than one department. So maybe the employee works in the math department as well as computer science. So in this case, department is a multi-valued attribute. Another kind of attribute that we have is a derived attribute. And this is an attribute that a lot of times is not physically kept. It is calculated and derived, okay? So it is a derived attribute. So for example, an attribute like GPA is calculated based on the grades, or an attribute like age could be calculated based on the birth date. So a GPA field or an age field could be considered a derived attribute. So a derived attribute is an attribute that is not recorded physically, but is calculated on the fly. And how do we show derived attributes? With dashed ovals. So if you look at the next slide, you will find that tax withheld is a derived attribute. It's a dotted oval all the way around. So that's what we consider a derived attribute. Now for the keys. So a key is an attribute used to find a particular record, or it is used to uniquely identify a particular record. So how do we show a key? So if you look at slide 20, you will show that we see that we have the FFN underlined. So a primary key is shown underlined in an ER diagram. Okay. Slide 21, we say more on keys, and we talk about strong entities and weak entities. I'm not going to elaborate on this so much here because we have a whole chapter on weak entities. So we'll talk about weak entities when we get to that chapter. Okay. The next few slides, we define the ER design methodology. Okay. So we talked about step 1. Okay, and in step 1 we had said where we would be selecting a primary entity and show the attributes and draw the ER diagram. Then we talk about step 2 where we use the structured English to describe the database. Okay, we describe the entities, describe the attributes, describe the keys, and this is mainly needed when you are designing a database, and you are, especially when you're designing, you're working with a software engineering group or a team, and these days a lot of stuff is outsourced. You need to design something. That stuff needs to be outsourced. So you're working with a big team, and it's a big database. That's when you need to design everything, document everything, make sure your entities, your attributes, and everything is documented. And that's the reason for having an ER design methodology. Okay, and the next few slides I talk about the structured English and what would be a good way to write out the English and write out how what the entities are, On slide 24, I write out what the attributes are, and I give you a sample English of how you would write what the attributes are. Then we talk about how you write the composite attributes, how to write the multi-valued attributes, and I show how to write each one of those attributes. Then comes the derived attributes. Then on slide 28, I show you how to write the keys. Okay. Now, going to the keys, or rather, so we talk about the keys, and then one candidate key for each element. Okay. Going to slide 30, we talk about a relational database. What is a relational database? A relational database is a two-dimensional table with connections to other tables. It is made up of rows, which are called tuples, and columns, which are called attributes. So the one thing that we will be learning throughout the book is the mapping or converting the ER diagram to structured English as well as to a relational database. Because if you can design a database and really design it nice and well and good, it doesn't do you any good if you cannot convert it into a relational database and put it into Oracle so that people can access your information. So designing it into a relational database will help you put it into Oracle or whatever software you would like to put it into. Okay, so throughout the book we will be designing or developing these mapping rules for mapping rules. So in this chapter, the one thing that we talked about was what is an entity, how to determine what's going to be an entity. Well, anything that we want to store information about is an entity. Well, an entity maps to a new table. So the first rule is develop a new table for each strong entity. Make the candidate key the primary key. And if there, so make the candidate key or the unique key the primary key. If you feel there's more than one candidate key or there's more than one unique key, then just pick one of them to be the candidate key, basically. Or, to be the primary key. So if there's more than one candidate key, pick one to be the primary key. Okay, so now, what are the mapping rules? So the first mapping rule we developed was to develop a new table for each strong entity. The next mapping rule is how do we map atomic attributes? You form a column for each atomic attribute. So for example, name was an atomic attribute. So we formed a column for name. Composite attributes. You form a column for each atomic part of the composite attribute. So you'd form a column for street, you'd form a column for city, you'd form a column for state. Notice that the primary key is underlined. Okay, then multi-valued attributes. How do you map multi-valued attributes? You form a separate table for the multi-valued attributes, and so create a column for the multi-valued attribute and take the key from the primary, take the primary key from the original table and include it in the new table with the multi-valued attribute. So for example, since department was multi-valued in that employee ER diagram that you saw a few slides back, department was multi-valued, so department becomes its own attribute or becomes its own column. And we take the primary key of employee, which is SSN, and add it to department, and we underline both SSN and department, and it becomes both SSN and department become the primary key. So this is how we map the multi-valued attribute department. And department does not show up in the original table employee. Okay. Every row must contain atomic attributes only. So what are we talking about? We're talking about relational databases and relational databases. Every row must contain atomic attributes only. Every row must be unique. There should be only one possible candidate key for all attributes. So basically, this is what chapter 2 is, chapter 4 is. where we basically define what we did today in this recording was we defined what an ER diagram is, we defined what entities are, we defined what attributes and relationships are, we developed the mapping rules for the entity, the atomic attribute, the composite attribute, the multi-valued attribute. So we developed the mapping rules, and we understood what an entity relationship diagram is. And with this, I'm going to end this recording right here. And I hope you've understood the session. And if you have any problems, of course, you do know that you can re-listen to this session. Thank you, and bye until next time.